In this video, we are going to be finding the limit of a split function or a piecewise function. We call split functions that too. So what is a split function or a piecewise function? Well, on a graph, it maybe looks something like this. We've got some sort of split pieces of our graph here. And who knows, these could kind of look like whatever you want them to look like. Right, we could come out like this. So it basically is just saying we have to represent this graph. This graph is all one function, but we have to represent it with pieces of other functions. So you put them together, we call it one function. Okay, so we're going to be able to find a limit of something like this analytically and not using a graph, okay? So this is a good example to start off with. We have, as you can see here, two pieces of different functions, and we're putting them all together in one function. And you can see here that they're defined for different values. So for anything that, any value that is less than or equal to 3, our graph is going to be negative x plus 7, and then anything greater than 3 is going to be 3x minus 5. So how do we find a limit with this? Well, it depends on what we're looking for, what limit we're looking for as x approaches what value. Our first example here, x approaches 3, this is going to be typical. You're going to see something that has these values put on there, because how do we find the limit exactly at that point? Well, we have to plug the value into our function for the value it fits at. Okay, but we can't just plug this into the equal one. We have to check both sides. And if both of these pieces give us the same value, then it does have a limit there. And we can actually say what the limit is there. So let's plug 3 into the top. Negative 3 plus 7 is 4. Plug it into the bottom. 3 times 3 is 9. Minus 5 is 4. Okay, yes, that means that there is a function there. Or sorry, there is a limit there, because both of them come to the same value at 3. Say one came to 1 and one came to 5, there would be no limit right there. Okay, because they're coming to different values. Okay, let's look at negative 8. Where is x getting really close to negative 8? Well, it looks like we don't have a whole perhaps or something there at negative 8. So we're going to plug it into the top function because that's less than or equal to 3. So negative 8 plus 7, or the opposite of negative 8 plus 7, this is going to be 15, and that's our answer. Okay? As x approaches 0, this is also less than or equal to 3. So plug that into the top function, negative 0, well, that's not a thing. Our answer is just 7. Okay? The next one, negative a squared. Okay, you might be thinking, I have no idea what this is going to be. Well, what do you know about a squared? What is our output of any a squared that we have? Okay, you might be thinking, well, it kind of is a quadratic function. It looks like a parabola. Well, that's right. But the thing that we need to know about a squared is that any value we plug into there is always going to be positive. Okay, so this kind of happens, it's going to happen on your homework, and we see this quite a bit. We just have to know, for whatever arbitrary value this is, output's always going to be positive. But you might be saying, Miss Dill, there is a negative in front. You're correct. So that means any number we put into this is going to have a negative output, because we know that a negative times a positive is a negative always. So where is this function always going to be negative? Well, in our top function again, the negative x plus 7, and we need to plug negative a squared in for negative x plus 7. So we'll have negative a squared plus 7. This is just a squared plus 7 then. So that means whatever value that a is, this is what our answer is going to be for that. Okay? Yeah, there we go. Okay, and then f of 3, this is not a limit, this is just a value. So this is where you have to say, well, now I know I have to plug this into whatever function is equal to 3, and that's the top function again. I realize this example, we're basically only using the top one, but that's okay. You'll be using multiple ones later. So plug 3 into the top, negative 3 plus 7 is 4. And that's how we find the limit of, or multiple limits of a split function.